I'm inviting you to join me for a journey. Let's suppose that we are following the life cycle of the project, starting from the inception phase all the way through the to a matured product. So a very normal question comes into my mind, and it sounds like, would you go microservices from the very beginning? Is this an appropriate architectural style, let's say? So, uh, not really. Most likely, Monolith first is the most successful choice. All the successful microservices stories have started with the monolith. A lot of products which started with microservices architecture from the scratch ended up in a very serious trouble because there is a lot of complexity, as we will see later. And it's way better to have a poorly designed but successful system instead of having a microservice which is not that successful. So Martin Fowler recommends us to start with a monolith first. Good. So the conclusion is pretty clear. You shouldn't start a new project with microservices, even if you're really sure your application will be big enough to make it worthwhile. So go for the very beginning with the monolith. Okay, so we decided that in our journey we will go with the monolith, but then how do we structure this monolith? So the answer to this is the modularization. Strong encapsulation, well-defined interfaces, explicit dependencies between modules. And we need stable boundaries between these modules. This is nothing new. We all know it from the very beginning. High cohesion, low coupling. It's super easy. We don't have to overcomplicate things. We just have to stick to the simple design rules and implement them very well. Simon Brown said, if you can't build a well-structured monolith, what makes you think microservices is the answer? So start first with a monolith, perform the structure very well, and modularize, find this monolith. Okay, so we went with the monolith, but how do I get the modularization right? How do I do the modularization in a good way? Again, Martin Fowler is teaching us that we shouldn't use presentation domain data, so layers, like in the left-hand side of the picture, for big enough monolith. We should go with the top-level modules, which internally they are organized as layers. And these top-level modules, they have to be domain-oriented. So this is, you would say this is something related to the microservices as well. Yes, it is. But we can apply the same principle also in a monolith. So we should go first with a domain-oriented separation, and then we should go with a layered architecture inside. So each module can have as well presentation, can have as well domain, and can have as well the data. So this is perfectly fine also inside the monolith. We don't need to go all the way with the microservices to implement this design principle. But then, okay, so we have modules. We continue our journey with the product. But how do we get the shapes of the modules correctly? How do we get the boundaries correctly? And once again, we have a lot of history. And the first principle which applies here is the Unix philosophy, which says make each program to do one thing and do it well. And that one thing can be as well as a module. It can be as well as a microservice, but we can apply it once again also in a modular monolith. So think about do one thing well. Again, if we take a look at the domain-driven design, it introduces the bounded context. The first class entity in this design are the domain models. So everything is shaped around the domain models. And we have to see the context where those domain models apply. And we have to draw the boundaries around that context. And that context became the bounded context. But in its core is the domain models which are dictating the shape and the boundaries. And we also have a very old paper written by Parnas, which says how should we decompose a system. And it shouldn't be related to the flowchart. So we shouldn't decompose based on the steps a customer is performing typically. We shouldn't take those 5 steps and create them as modules. We should put into the modules we should hide in these modules difficult design decisions. And those decisions should be hidden from the outside. So this is a way we can design as well modules. So we have plenty of recommendations how to design the module. As well, if we figure it out, for instance, that the modules are not shaped correctly, and we want to move around classes, because yeah, we are in Java at this conference. Then it's pretty easy. We don't have to rebuild. We don't have to redeploy. We don't have to see runtime errors. Being in a monolith, it's way simpler to reshape the modules. We got compile time errors. We got the unit tests which are failing, and they are failing very fast. We don't need to hit the production to reshape these modules, and this is pretty important. But before migrating to microservices, we have to understand this extra complexity microservices are giving us, because it's not simple at all. One and the foremost complexity is the data consistency. In a monolith, we have a database transaction. We have ACID. We have referential integrity. We have all or nothing. The database remains in a consistent state. There are very few consistencies, and the consistency is guaranteed by the database. In a microservices world, things are changing, I would say, dramatically. We have in this context eventual consistency. We could have as well distributed transactions, two-phase commit. We could have the saga pattern. Distributed transactions are typically slow, and they are not guaranteed. So even if two-phase commit, if the first phase runs fine, the second phase may end up in an error. Moreover, in distributed transactions, the communication is done synchronously. So there is a lot of performance penalty for implementing distributed transactions. And people are using distributed transactions less and less often. An alternative to distributed transactions is this saga pattern. We do a commit in different systems, in different microservices, and if the last call to another microservice fails, we just roll back, we do a compensating transaction, we do a compensating work on the previously successful requests. This is not guaranteed as well. And also this compensating rollback transaction can fail as well. So eventual consistency or the consistency, it's weakened, and errors may happen from time to time. It's very important to understand also the business model. For ERPs or for financial services, this eventual consistency may not be an option, and we need database transactions. So related to the business you are designing, you can go with the microservices or not. But just bear in mind the data consistency, it's weakened a lot going with the microservices. And we have network fallacies. So we think that the network is reliable. When we migrate from the monolith to the microservices, we do a network call the same way we do a method, local method invocation. And it's not the same. Network calls can fail at any time. The complexity is increased. Maybe we have to implement the timeouts. Maybe we have to implement retry mechanisms. Maybe we have to implement circuit breakers. So it becomes really complex, these network calls. Moreover, the latency is not zero. If we do many downstream microservices calls, they add up, and a perceived latency of the system, response of the system, is increased. I heard projects which were putting back services in one service, merging services together because of the latency issues. But you have to experiment this on your own to realize that the latency is really an issue. Okay, let's move to the next slide and go to continuous integration and continuous delivery. With the monolith, it's typically one single pipeline. You have all the steps from deployment pipeline, like the build, the unit test, deployment to the stage environment, acceptance test, and deploy to production. This is pretty easy and doesn't require a lot of people to maintain it. If we go with the microservices, we'll have plenty of these CI/CD pipelines. Sometimes I'm calling them deployment hell, if you wish, because we need a lot of people, we need a lot of tooling, we need a lot of understanding to deploy the microservices correctly. So this is not an easy job, and you need to have a lot of people to implement this. With a monolith, it's easier, and it's again easier to maintain. The same we go with the monitoring. With a monolith, we monitor the runtime systems, but they are just a few. They are not many. With a microservices architecture, we have to monitor all the services. Of course, all the tools which have been developed lately, like the Kubernetes and so on, they help us maintain the systems running. But we need more alarms. We need more dashboards. And actually, we need more people to manage the services. If you have a pretty small team, even if the code base is quite big, a monolith can still be the answer for you. What about the integration testing? Cindy is talking about it in the service mesh context, but this question is still valid for the microservices architecture. How do we test end-to-end a complete flow? Do we fire up the entire fleet of microservices? How should we do it? It's not easy and it's not trivial. Charity says, as a reply to Cindy, that the integration testing is not effective for complex distributed systems. It requires an infinite cycles of development, of refining, and the payoff is not that obvious. So most likely you could spend a lot of effort in implementing integration testing and still they can be ineffective. So this is, yeah, pretty scary, I would say. With a monolith, it is better. You can test it on a local environment and you can run the integration tests as well. Very simple. Security. Of course, we need some sort of a single sign-on also for the users, but for the service to service, because the services, microservices, they communicate with each other. And for the end users, a simple approach is to have a single sign-on gateway. And this single sign-on gateway is checking the authorization credentials toward an identity provider. We have this single sign-on gateway not to duplicate the authorization logic in each individual service. We don't want to have the redirect links in each individual service. So this is one of the best approaches to have the single sign-on a gateway level, on the edge service. We can go with the OpenID Connect, but again, this is extra complexity. With service-to-service authentication, we can go as simple as basic authentication over HTTPS. We can still go with the OpenID Connect. Maybe we can implement client certificates or API keys. And most likely, from time to most likely, there are scenarios or edge cases when an end user is not involved in some of the scenarios, and we need service accounts. So this security area becomes really complex if we want to go in a microservices environment, really complicated. Attack surface area is increased because we expose many microservices. Of course, we can keep some of the microservices in a private network. That's true. And we don't want to repeat ourselves. The authentication, that's why we have this gateway, single sign-on gateway. But there are times when each service is performing this redirect response. This is repeated across all the microservices. So there are situations when we have to repeat ourselves in the microservices related to the security. Oh, this is a tough one. Kelsey says in 2017, for the 2020 prediction, monolithic applications will be back on track after people discover the drawbacks of distributed monolithic applications or the microservices. So going distributed, it's hard, it's difficult, and it's complex. Cindy says something similar. Microservices are hard. Effective testing, it's hard as well, and it requires a lot of tools and a lot of know-how. And she says that not any company, it's a Netflix or Uber style company. And then the question is, why microservices? Martin Fowler has a very suggestive image. You have to be that tall to use microservices. You need to have in your organization a lot of know-how, a lot of experience, and a lot of people to go microservices. Microservices are an organizational change. And you have to do it consciously. There are on the internet some talks which discuss about the drawbacks of the microservices. Here are most known ones, like avoiding microservice mega disasters or the microservices highway to hell. I encourage you to also take a look at these videos. Once again, microservices could be an answer for you, but the decision has to be completely conscious and cautious. You have to understand upfront the microservices complexity. And by the way, customers don't care about your technology stack. You are just selling features. If you overcomplicate things and if you don't deliver business value to your customers, that this can ruin your business. Yeah, why migrating to microservices? One of the reasons is scalability. You can independently scale the microservices. This is time and cost efficient. Like you can do auto scaling. You have fast startup time, low memory footprint. So this runs fast. It can be stopped fast, and you can bring new nodes very quickly into your cluster. It is also CPU and memory. It can be designed. It can be used also for the CPU and memory intensive applications. If you need more CPU power, only that specific microservice will be upscaled, and you will have multiple instances to carry the workload. They say microservices is the target also for autonomous teams. This is the hard one. Typically, they say on paper the teams are autonomous, but they depend on each other. They depend on the features of the other microservices. So in practice, the teams are not that autonomous. It's hard to get the teams to have the teams totally independent of each other because they form together a product. Also, one of the reasons to migrate to the microservices is you want to deliver faster business value. This is happening also because of the slow CI/CD pipelines. Why don't you improve those pipelines? Why don't you do things in parallel? There are a lot of ways to optimize the CI/CD pipelines instead of jumping on the microservices boat. Another reason to migrate to the microservices, this is a funny one. It's for us, for the developers, because the developer experience is bad and it's hard to maintain. And there are plenty of classes together. And if you have to start your application, it takes like 2 minutes, 3 minutes, maybe more. And it's not productive. But hey, maybe you can improve that as well. Think about it. I've heard a lot of questions about how more small can a microservice be. Should be this small, should be a picoservice, a nanoservice. It's it's funny question, a funny question. I challenge you with another question. How big a monolith can go? Yeah, we are scared of the big things because they are hard to maintain. This is true, but let's see how big we can go in our journey without our product. As a short recap, we decided to go monolith first, and also we want to do the design right of the modules. The first overlooked step is to horizontal scale everything. Instead of having only single app, we can have several apps, and these apps can stay behind a load balancer. The key point in this step is to have stateless application. Actually, we need to externalize the HTTP session, and we need to put it in some in-memory store like Redis. Because subsequent requests done by the users, they can be picked up by a different app server. And this will buy you some time. Your application can run smoothly without any issues. I think you can run years depending on the application type and the number of customers. You can run years with being at this step. Of course, over the time, if your customer base is getting bigger and bigger, which would be the point, which will be the bottleneck into the system? Typically, is the database. Because there will be more queries, you can bring up more app servers, but you will have more queries to be served by the database. And after a certain point, the database can scale. In this situation, you can go to the next step and bring into equation a read replica. Read replica can take select queries, read queries, and can take any read specific requests. So for instance, HTTP GET can be easily handled by a read replica. In this step, we offload the writer, the main database, with a lot of read requests. And the application decides on which database the query will be run. This will buy you also some more time. You can easily bring new replicas. If your application is read intensive, you will have a lot of success with this approach. You can bring in more replicas. I just want to mention here that the replication between the master and the read replica is taking a while, typically milliseconds. And in this situation, the consistency of your application is going to be relaxed a bit. You need to be careful if some stale information is accessed. For instance, you create an entity, it just goes to the writer, and you need it to read right away. But you do it from the read replica, but the information is not there. So you have to design carefully also the application to accommodate this kind of situations. What's happening if the information is not right? How do you handle it? Okay, there comes a time when also this approach is not viable anymore. Once again, we are still with our monolith. We can go and perform the sharding. So we can take the customers and split them in 3 databases, independent databases. We can route the requests at the load balancer level to the right app nodes, which are attached to the right database. So if some request comes and it's related to a customer A, it will go on the left-hand side. This approach will give you also a lot of years to come and to accommodate more users, more traffic, more customers. It will be a bit difficult if you want to repartition this information. You want to reorganize it over these 3 databases in this situation. It will be, pretty difficult. But once again, we are still with the same monolith. The very same code runs on all the application nodes. The very same code. It's not changed. And you have to maintain a single code base. You don't have to maintain 20 microservices. If your team is not tall enough, and if your team is suited for a single code base, this approach could also be fine for you. Sharding is not easy at all. You have to design it very carefully. On paper, it's straightforward, but in practice, it's not. Oh dear. Shopify. Of course, 2021, last year, it was the biggest Black Friday Cyber Monday ever. What do they achieved with the monolith? Yes, they have a monolith. They achieved 30 terabytes per minute of egress traffic. 30 terabytes per minute of egress traffic. That's really a lot. If I wouldn't tell you it's searched by a monolith, you wouldn't believe me. That's massive. It's around 43 petabytes per day. And you can search for this tweet and to see also some insights related to this post. I also would like to tell you about the product I'm working on. It's called TripleText. It's part of the Visma family. We are about 60 developers. We are organized in 13 individual teams. We are running on Tomcat, on Amazon Web Services, we have a MySQL database, and we are doing perfectly fine with the modular monolith. We have around 25 releases per day, and with some tweakings and adjustments also to the build pipeline, this is running perfectly fine. So 60 developers, 25 releases per day, and the experience is really nice. As a summary on our journey, microservices, the level 5, is the last resort option, and it should be a cautious decision, a really cautious decision. There are 4 more steps until you reach this microservices point, in my opinion. Level 1, you have to go with the monolith first and do the right design. Do the right modularization. Do the right decomposition. Level 2, horizontal scaling. You have to design it stateless. Sometimes this is a challenge. Level 3, you can bring in database replica. Level 4 is the database sharding. In my company, we are at the level 4. And I can tell you the horizontal scaling and the database read replicas bought us some years of bringing new customers into our product, and it's running fine. Right now we are the database sharding, and I think we will see each other soon to give you details about this step. Okay, and the last resort, is the microservices choice. Okay, so this is the last slide. Thank you. Let's see if we have some of the questions.
Thank you, Petru. Very insightful, to be honest. I mean, I like very much your pace in the presentation and the way you explained why should we be cautious and conscious, and why should we be intentional about such a an important architectural decision, actually. And I totally read your message not as something against microservices, but against maybe just jumping on the hype because it's cool, and because every decision has effects, and we need to understand them upfront. So you're at level 4, but tell us a little bit about the product itself. I mean, to understand the wider context. And
so the triple text product is an ERP system. So it has functionality like salary, invoicing, orders, warehouse, products, and stuff like that, functionality like this. And we are working also on the modularization, honestly, because some of the modules are well shaped, others are others are not, let's call it this way. And it's very nice, at least because we can refactor code and we can see if something is failing right away. So this is a good benefit.
in terms of, I don't know, clients, throughput, load.
I think we have thousands of requests per second. We have a very good monitoring for this. We use the Elk stack. We use the Amazon services. The database, it's around 7 terabytes of data, so it's a MySQL database. We use 3 read replicas, and those replicas are taking a lot of traffic. And typically, I think read-write ratio is 1:5, so one write and 5 or 4 reads. And bringing into the game this read replica, of course, it costs more because there are 7 terabytes of data, but we can see that response time decreased by a lot, and we provision new accounts, new companies, new customers, new accountants. We link accountants to companies, so there is a lot of traffic going on, and it's doing fine. So just a load balancer, and we have 13 node applications. Yeah, 13, 3. Yeah. It's interesting. It's challenging.
And thinking of the future, I mean, would you see doing, I don't know, any breaking the monolith, or I don't know? And have you analyzed, the possibility, and if yes, what would be the circumstances where you would say, well, this is the moment at least to prepare doing the break?
The question is about the microservices is to deliver faster business value. 25 times a day, do you need any faster? That's a simple question.
Probably not. Yeah.
Probably not. Another bottleneck in this architecture could be, for instance, the database. If you hit a lot of traffic into the database logs, they may appear, and they can block other customers, and yeah, the system can struggle a bit. But if those issues are not there, we don't see any reason to split the monolith and to go to the microservices approach. I just want to tell you one of my words, it's good to be microservices ready. So it's good to have the modules done right. This is a mandatory step if we have to go to the microservices. If we don't have the microservices, it's not possible.
Yeah, absolutely. And this is, links perfectly to one of the comments and questions from the audience coming from Terence, which is, well, let's suppose that the monolith is modularized enough to be prepared for the microservices. Now the question is, when is it the project big enough, or so to make the decision, or would you think that the maintenance of the monolith is, I don't know, more difficult?
If we split the code base, would it make it more easy? If some requests are traversing multiple microservices, would it be easier to test? Would it be easier to reproduce locally? I think not. One of the reasons is database-wise, because sharding is really hard. And we had several sessions, internal sessions related how should we shard the information. Because our database, it's highly linked to each other. So it's highly relational because accountants have access to the companies, to the customers, and so on. And it's pretty hard. How can we shard this kind of a global information? You can't do it. It's difficult. How should we handle those situations? Should those be on all the shards? So it's complicated. One of the reasons to migrate to the microservices is that you've done all the 4 steps, all the 4 levels, but it still takes like a while to release new functionality. I've seen products, they run the deployment pipeline like 3 hours or 4 hours. So that's a lot. And the question is, won't you want to do it faster? Yes, you want. Don't you want to release it faster to the customers? Yes, you want. And should we all have to wait into the queue of that deployment pipeline? if we all queue up, all the developers will queue up and stay in the queue to release it. And if you lost the train for today, you will have it for tomorrow, but that's not sure. So if you can release faster business value, microservices could be an answer. But again, one of biggest showstoppers for us is the database transactions. Because of the transaction isolation level. When you start a transaction, you want to base all of the business logic on a database snapshot, on that isolation level. You don't want to mess it up. You don't want to do accounting based on new and fresh information. So it's not really related to consistency. It's also related to the isolation. When you start to do some end of month report, you have to have a snapshot of the database. And that's happening when you start a transaction. Typically, transactions, they resist the microservices split. You cannot do that. It's hard to do Saga pattern to have the compensating request, and it's rather impossible to have the two-phase commit. So if the consistency is super important for you, yeah, it's difficult.
Yeah, I totally understand. And to me, these are just, two options, and you have to continuously do the trade-off analysis, do the look ahead, understand what the future will look like, what will be the business objectives and imperatives, and what do you want to achieve. And then the right moment in time, of course, you'll, take the right actions. But it doesn't make sense to introduce complexity upfront without understanding if there is a real
A
need
good reason
for that complexity.
Yeah. Brooks says about the accidental complexity is the one you didn't really realize it's introduced, but it's there.
Exactly.
So that's why I put the slide related to the cautious and conscious decision. It's really important to understand because you've seen there are talks related to the microservices mega disasters, and they will come more and more. And maybe there is a circle when the monolith may become the new trend sometime in the future.
Yeah, and people in the audience are also suggesting or asking, but I would rather take it as a suggestion to consider what would the cost be for a monolith versus the microservice and so on. So I'm pretty sure you already have this answer. I think it's a continuous analysis that you have to do, and then you are prepared, knowing your options to make a decision at the right moment in time. Let's not say at the last responsible moment because that might be too late, but at the most responsible or the right moment in time.
You know the Yagni principle. You aren't going to need it.
Yeah, exactly. Petru, it's been a real pleasure to have you at Codecamp. Yeah. Any final thoughts? Any final
note,
recommendations?
My feeling that the cloud providers they are selling microservices. They want us to have plenty of those, and they want to charge us as much as they can. So they will always advocate for microservices, always. So we have to do a cautious decision.
Absolutely, and they're doing it for also for business decisions, but it's their decision. Yeah, absolutely.
Yeah.
Good. Any final thoughts for us, Petru, today?
Yeah, that should be it. Super happy that you invited me to the Codecamp, and thank you everyone which attended my talk.